Hello everyone, this is a video on relative pose and translation. It's quite short, but it contains some fundamental information we need when moving forward. So, first we need to consider reference frames. It's important to understand that both position and orientation in space is relative. Therefore, we need to consider both to fully describe 3D space. So, when we combine position and orientation, we call this pose. Right, so transforming between reference frames. So when we move between reference frames, this involves both a translation and a rotation. So we need both of these to describe pose. So let's look at an easy example of position and translation in a common reference frame. So we have 2 points in 3D Euclidean space. So we have P1 described by its position x1, y1, z1, and we say that this is in the set of real values in three-dimensional space. Then we also have P2 described by x2, y2, z2 coordinates, which is in the set of real values in 3D Euclidean space. Then the translation between these 2 points is simply P2 minus P1. So the x coordinates will be x2 minus x1, y coordinates y2 minus y1, z coordinate z2 minus z1. Again, this is in the set of real values in three-dimensional space. So what if we consider position and translation in different reference frames? So we have 2 reference frames with different position and orientation. So we say that they have a different pose. So here's frame 1 and here is frame 2. And I'm going to specify a point in frame 1 with the superscript 1 here. Then the question would be, what is the distance from frame 2 to this point with the superscript 2? To denote that this point is now being referenced to frame 2. So to answer this question, we need to consider the relative orientation between reference frames, and this requires a bit more complex mathematics. So we will learn about these in future videos. So a quick summary of relative pose and translation. Pose is the combination of position and orientation. We define a point in 3D Euclidean space as this vector P with x, y, z coordinates. The translation between 2 points in the same reference frame is simply the point P2 minus P1 given by this equation here. Again, it is in the set of real values in three-dimensional space. And lastly, to describe translation in different reference frames, relative orientation must be considered.